In this video, we'll be discussing a clipper circuit. So that is an example of your biased clipper. So what is a biased clipper? So as you see in this circuit, one extra DC source is connected here. So when a DC source is connected along with the diode in a clipper circuit, it is called as a biased clipper circuit. And once we get the output, you will understand that why it is called as a biased clipper circuit. So what is the input given here? So input given here is 10 volt of maximum peak in positive side and minus 10 volt of maximum peak in the negative side. And then it is given consider the silicon diode. So we have to represent the diode as a potential barrier or equivalent voltage drop model. While it is in the forward bias, while it is in the reverse bias, we have to consider it as a open circuit. Now here again we can divide the signal into parts. So I'll take 0, here it is t by 2 and I'll take here t. Okay. So in first part is 0 to t by 2. So for 0 to t by 2, what is happening? Let us see. So in 0 to t by 2, I'll draw the circuit here, then we'll be explaining. So remember, while doing the clipper clumper circuit, all the part of the way we are taking, just draw a circuit again so that you will be get more clarification and you won't have any errors there. So here we are applying for 0 to t by 2, 10 voltage is applied here. Okay. In this case, when 10 voltage is applied here and this voltage is given as 5 volt. Okay, now when 10 voltage is applied, for this diode, positive side is here and negative side is here, right? So that means this 10 volt is trying to make the diode as forward bias, first condition. Next is 5 volt battery. So see, the negative side of the 5 volt is connected to negative of the diode. That means this battery is also trying to make the diode as a forward bias. Now in both the cases as the diode is forward bias, so what I can do here is, instead of having the diode, I can represent that as a potential source. So right, so what will be the potential source? From positive side and negative side, and this value will be 0.7. Now this is the case when the diode is forward bias for 0 to t by 2. And here we need to write what is the output voltage. So what is the output voltage? So whatever potential drop is available at R resistance, that is my output voltage. So now the current is flowing in this direction. So plus terminal is here. So current is flowing in this direction. We need to write the voltage equation. How we can write the voltage equation? So first let us see. First is 10, positive 10. Then plus to minus is there. That means minus 0.7. Then 5 volt is there, from plus to minus to plus because the battery direction is already given. So it is plus 5 volt. And then so here it is plus, here it is minus. So minus V0, that is equals to 0. That implies V0 is equals to, if I calculate 15 minus 1, so it is 14.3 volts. Okay, so this is my V0 value for the first half or 0 to t by 2. Now let us see what output we are getting for the condition where for t by 2 till t. Okay. So in t by 2 to t, so what voltage I am getting? I'll just draw the circuit again. So here 5 volt is connected and here the load resistance is here. So this is minus 10 volt. So minus terminal is here, plus is here, and applied voltage is 10 volt here in this case for t by 2 to t. This is 5 volt. Now what will happen to the diode? So see here, a higher potential is connected in negative, means in reverse bias condition. That means for the diode, this is positive and this is your negative, and the 10 volt is making the diode reverse bias, but the 5 volt is trying to make the diode forward bias. In this case, as the 10 volt is higher, so what will happen? The diode now will behave as a open circuit. So for open circuit, what I have to do? I have to just replace the diode with the open circuit. That means now what will happen? Now there will be no current flowing because the diode cannot be forward bias in this case because 10 volt is higher. So there will be no current flowing. So what will happen? So voltage appeared across here V0 will be equals to 0 because no current is flowing, right? Now how do we draw this equation? So for that I'll just draw this waveform. I'll just extend this graph and here I'll take the reference line. Now let us see. For 0 to t by 2, So for 0 to t by 2, what is my voltage value? 14.3. Okay. So in this case, I'll just draw one more line here. For 0 to t by 2, my signal value is positive 14.3 we are getting here. Next, for the next term, t by 2 till t, what is my output value? Output value is 0 here. In this case, so for this period of time, the output value is 0. So what is the final signal for me? So this will be the final signal, output signal from me. So this is the 0 line and this is 14.3. So this is how the output will be there. Again, once the negative other half, what will happen? Again it will go to this part. So like this it will continue, and this is the output of a biased clipper. Biased clipper means just a battery will be connected there, nothing else. So while analyzing, you need to take care that what is the direction of the battery, what is the polarity of the battery, it is connected to the this diode. Okay, accordingly you have to do the analysis. So if it is connected in this way, here I have taken in the equation plus 5 volt. If it would have been connected in the other way, here I would have to take minus 5 volt, and the answer will be 10 minus 5 minus 0.7. Answer would have been your 4.3 volts, not 14.3 volts. So while doing the solution, you take care that what is the, where is the battery connected, whether the battery is more than the input voltage or not. If it is less than the input voltage, then the input voltage will decide whether the diode is forward bias or reverse bias, and like this you can do the analysis. Okay, so in next video we'll be doing one sinusoidal analysis with a biased DC biased clipper.